Hey class, today I'm going to teach you guys about how to find the prime factors of a number. So first, what you need to know is some definitions. The first would be, what is a prime number? Well, a prime number is any number that only has two factors, which is two multiples to itself and 1. So any number that only has those two numbers that can multiply to give you that number, that is your prime number. The numbers that have more than 1 are called composite numbers. So let's look at some examples. 3 would be a prime number because 3 times 1 is the only multiple of 3. 5 would be a prime number because 5 times 1 is the only multiple of 5. But 12 would be a composite number because you can say 4 times 3, or you could say 2 times 6, or you could even say 12 times 1. All these equal 12, so that would be a composite number. So now that you know the difference between a composite number and a prime number, we can get started on learning how to take a composite number and finding the prime factors of that number. So first, let's start with an example. And I'll show you there's a couple of different ways that you can do this. You guys can choose whichever way you feel most comfortable with. And we'll start with the tree factoring, the prime factoring, like the tree branch method. And we'll use the number 36. So 36, well, you want to start, you make two branches on the other side. And you find two composite numbers, if possible, which will make it easier for you, to put on either side. So 6 times 6, and they both have to multiply to give you 36. That will give you 36. And then you can break down the 6's further, because these are not prime numbers yet. So you keep going until you get to a prime number on every branch. So 3 times 2 will give you 6. 3 times 2 will give you 6. These here, all 4 of these are prime numbers. So we've got the prime factors right there. So 3 times 2 times 3 times 2 will give us 36. And if you're not sure that you did it right, you can always multiply these back out and check. So 3 times 2 is 6. 6 times 3 is 18. 18 times 2 is 36. And so that is how you would factor using the tree factoring method. The other way you can do it is just by using division. Say you want to find the prime factors of 34. You would draw a box around 34 and you would say, what is a prime number that will go into 34? We know 2 will go into 34. It'll go into 34 17 times. Alright, well that's the end of prime factoring, because you go until you get a number that will no longer can no longer be divided a prime number into, because it is a prime number. So you go until you get a prime number. 17 is a prime number because only 1 times 17 will give you 17. There's no other number. You could try it and you would find that it's a prime number. So the factors of 34 are 2 times 17. So now you guys know how to find the prime factors of composite numbers. Next, I want to move into a little bit of application of how you can apply this knowledge into many different aspects of math. One thing that you can do, we're going to talk about more of these in class, like greatest common denominator and least common multiple. We're going to talk more about that during class, but today I'd like to show you guys how to simplify a fraction using this knowledge of the prime factoring. So let's give an example. Say that you have 22 over 32. And you want to simplify this fraction. So the first thing you would do is you would take each number one at a time and find the prime factors of that number. So starting with 22, we'll use the tree branch factoring method. 22, break it into 2, and this one's actually going to be pretty easy because we know that 2 is going to go into 22, and 2 times 11 is 22. And these are both prime numbers, so that would be as far as we can factor this. So we would write this here, 2 times 11. It's going to go over 32 once we factor it. So 32, let's use the division method for prime factoring. 32, divide that by 2, and we'll get 16. 16 is not a prime number, so we can continue to factor that. So let's divide that by 2 again. We'll get 8. Divide that by 2, we'll get 4, by 2, 2. So for 32, we're going to get 1, 2, 3, 4, 5. 2 is going to happen 5 times. So 2 times 2 times 2 times 2 times 2. And another way that you can write this, instead of writing a big strand of 2's, is you can say 2 to the 5th power, because 2 is happening 5 times. This is called an exponent that you can write above your 2, which is 2 to the 2 to the 2nd power would be 2 happening twice, 2 to the 3rd would be 3 times, or 2 squared, 2 cubed. But we'll worry about that later on, and for now we'll just write 2 out 5 times. And so the rule is, if we have a number in the top and a number in the bottom that are the same, and they're multiplied by the other numbers, as long as they're in the top and the bottom, they will cancel each other out. So we have a 2 in the top and a 2 in the bottom. They will cancel each other out, and we're left with 11 over 2 happening 4 times, and 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, so you can go ahead and multiply that out. So 11 sixteenths is what we're left with. So we know that 22 over 32 is the same as 11 over sixteenths. So that is how we can use prime factoring, our knowledge about prime factoring, to simplify a fraction. And so I want you guys simplify fractions. We used all the steps that we knew. We knew that this is a composite number and that's a composite number. And we knew that if we used these different factoring methods, the tree prime factoring or the division prime factoring method, that we could find the prime factors of these two numbers. And we knew that if we canceled out the common numbers amongst the two, we could simplify our fraction. And so that is one way that we can use prime factoring to simplify things when doing math. So I want you guys to practice what we've learned today and come prepared to work a lot of problems and learn more about prime factoring. Thanks.